Hey everyone, so welcome to today's lecture on foreign policy decision making. So we're changing a little bit over from theories and getting a little bit more applied. So hopefully you'll enjoy it. Still theoretical, but moving away from some of the bigger theories into kind of a little bit more of how decision makers actually make decisions on the ground. All right, so we're going to start with back in the early 1960s, Graham Allison produced three conceptual models for decision making. So there was the rational actor model, and this was that model that already existed. So people were already assuming that in making foreign policy decisions, decision makers were acting rational. But then he also proposed two alternative models to depart from the rational actor model. The first being the organizational process model, and the second being the bureaucratic model. So we're going to review each of those, and then we'll move on to kind of some alternative viewpoints on how foreign policy decisions are made. So we'll start with the rational actor model. And before we get into kind of how Allison talked about the rational actor model, I just want to review a little bit kind of some of the how rationality and decision making is looked at in political science and economics and psychology when it comes to making choices rationally. So there's all kinds of different models of how people make rational choices, but this we're going to look at is the expected utility theory, which is one of the more prominent ones. So let's start, and don't worry, we're going to have a little bit of math in some of these. This is just kind of for illustration purposes. Never on the exam am I going to kind of give you calculations and say, what is the expected utility here? This is just kind of more to illustrate it. Some of you will, I hopefully really like the illustration. Some of you, who aren't particularly big fans of math may not enjoy this as much. That's okay. This is just to try to help you understand a little bit. So consider you have a choice, right? And you have a choice between having a 50% chance of winning $100 and a 50% chance of getting nothing. So essentially you could get like a lottery ticket where you have a 50% chance of 100 and 50% chance of 0. Really, that would be a really nice lottery in terms of probabilities. Or you've got a 100% chance of getting $45. So think about here, and there's actually no right or wrong answer here in terms of whether you prefer the gamble, so the 50% chance of 100 and 50% chance of 0, or do you like the 100% chance of $45? So think about if you were given this offer, which one would you choose? And again, there's no right or wrong answer here. It comes down to your risk preferences as to which one you would select. But we'll take a look at a little bit how you find what is the value. If you're thinking rationally, what is the value in these different options? So expected utility theory is based on self-interested pursuit of gain by national leaders on their own behalf and on behalf of their nations, right? And expected utility theory doesn't only apply in international politics, so this could just be self-interested pursuit of gain by any individual in their own lives, but it also does apply to leaders either going for their own individual gain or for the gain of their nations. And there's a few assumptions that are always made, in expected utility theory. And if those assumptions are violated, then the theory is not expected to operate. We would not be seeing rational decision making, right? So preferences are ordered, right? And this is simple here. For the first few examples, we'll take the example of ice cream, right? So imagine there's 3 different ice cream flavors. So you've got chocolate, vanilla, and strawberry, right? So preferences are ordered, just means that you have an ordering in how much you like each of these, right? So you know, do you like chocolate more than vanilla and vanilla more than strawberry, right? So say we'll go with preference order, and chocolate is best, vanilla second, and strawberry third. Preferences are transitive, right? This simply means that if you prefer chocolate to vanilla and you prefer vanilla to strawberry, you also prefer chocolate to strawberry. So you don't have this like wacky, like you prefer chocolate to vanilla and then vanilla to strawberry, but then strawberry the chocolate, right? Uh, you don't have any kind of wacky circular preferences. If you prefer A to B and B to C, you also prefer A to C. Alternatives have utilities, right? Utilities, oftentimes when we're actually looking at it, utilities are expressed in terms of dollars, right? So in the lottery example, it'd be like, you know, the utility would be, you get $45, right? So you get a certain level of kind of, you think of it in terms of the reward or the value. But it doesn't have to be, utilities don't have to be expressed in terms of money. They could be expressed in terms of any other form of valuation, right? Like, so in terms of the ice cream, it could be in terms of happiness, right? If you could measure happiness, chocolate brings you like super happiness, and vanilla brings you strong happiness, and strawberry just brings you happiness. And if you could quantify that into some form. But usually in most of the examples, you often see an expected utility is expressed in terms of money. For each alternative, decision makers multiply the probability of achieving each outcome by the utility of the outcome, right? So probability of the outcome and the utility, right? So for example, if we want to find the utility of the option or of the outcome of getting the 50% chance of $100, right? So 0.5 for 50%, and then $100. So 0.5 times 100 would be 50, right? Or $100 times 45. Probability of 100, so 1, and outcome 45, so 45, right? So for each of the different outcomes involved, you could find what is the expected utility of it, of any particular outcome. And so just always remember, if you got 50%, transform that into probability. So 50% being 0.5, 100% being 1. So probabilities always have to be expressed between 0 and 1. 0 being 0%, 1 being 100%. And then decision makers select the strategy that maximizes their expected utility, right? So if you take, okay, so the choice, the 100% of getting a chance of getting 45, right? You look at what is the expected outcome there. You take the full choice, so the $100 one, and combine it with the $50 one. You look at the how much utility you get out of that, and you choose the one that makes you happier. In the chocolate, vanilla, strawberry one, right? So you take a look at, you have 100% chance of getting each of them because you can choose, right? So you choose the one that has the highest utility. In that case, it'd be chocolate. Now, in terms of the calculations that we're talking about going on here, like the multiplying of probabilities times outcome, decision makers don't actually, like most rational actor scholars, don't actually assume that decision makers actually perform these calculations. Instead, we talk as if they act as if they had. So as if they had done these calculations. All right, so let's see this kind of worked out with all the different stages here, right? So again, we've got the 50% chance of getting $100 and 50% chance of 50, or 100% chance of getting 45, right? So first step, we need to identify all of the different options, and we need to make sure that they are ordered, okay? So there's 3 possible outcomes here, right? You can get outcome 1, where you get $100, outcome 2, where you get $0, and then outcome 3, where you get $45. At this point, we're not bringing probabilities in. We're just ordering how much do you like each of these, what are the possible outcomes, and how much do you like each of them, right? And in terms of notation here, so O, we say, is representing outcome. So O1 is outcome 1, O2 is outcome 2, and O3 is outcome 3. And then at the bottom where you see U, that's just saying utility, right? So again, happiness or value or money in this case, right? So utility of outcome 1, utility of outcome 2, utility of outcome 3. So that's just essentially another way of saying the utility of outcome 1 is $100. Utility of outcome 2 is $0. Utility of outcome 3 is $45. What do you get if you get that outcome, right? So we could show that the preferences are ordered. We prefer outcome 1 to outcome 3 to outcome 2. because we prefer 100. At least I assume all of you would prefer getting $100. Your second favorite choice would be getting $45, and your least favorite choice would be getting $0. For most people also, we would assume that the preferences are transitive. So you prefer A to B, you prefer B to C, you also prefer A to C, right? So you prefer getting 100 to 45, prefer getting 45 to 0, and you prefer getting 100 to 0. So we've satisfied preferences are ordered and transitive. Okay, alternatives have utilities, right? So each different alternative here, we have a certain outcome, right? We've assigned dollars to them, so 100, 45, 0. Outcomes have utilities. All right, so then for each of the alternatives, decision makers multiply the probability of achieving each outcome by the utility of the outcome. Okay, so here we're going to get a little bit more notation heavy. But so here we're going to start by looking at the choice of the gamble versus the sure thing depends on whether the expected utility for this is pretty much what all of this is saying. So whether you choose to have the gamble or whether you choose the sure thing depends on whether the expected outcome, and hang on, I'm just going to turn on the highlighter here for annotating. All right, so this here is representing, and we'll unpack it in a second. This is representing the gamble, and this is representing the sure thing, right? So we're saying that you would choose the gamble if the expected outcome, the expected utility, is greater than the expected utility for the sure thing. And you would choose the, and then you would choose the sure thing if the expected outcome for the gamble is less than the expected outcome for the sure thing. So that's what all of this means, right? So you've already seen U of 0 of O1, right? So you already know what U of O2, U of O3, right? Utility of outcome 1, utility of outcome 2, utility of outcome 3. So what does the P mean? That's just the probability in that next stage of the calculation, right? So let's start with the sure thing, right? Probability of the utility of outcome 1, right? Probability of probability for the sure thing was 1. So see down here, we replace the P with 1. Utility of outcome 3 is 45. Here, we've got probability of the utility of outcome 1, right? So we replace P with 0.5 because it's a 0.5 probability of getting the utility of outcome 1 is 100, right? Now, why do we have this 1 minus P, right? So you could have like a P2 instead or something like that. It's just to show that probabilities always have to sum to 100, right? You can't have anything left out. So if, just in terms of notation, if you want to make sure that nothing gets left out, if you've got two options and one of them has probability of P, then the other one has to necessarily have probability of 1 minus P. So imagine you had something where there's a 70% chance of getting something and a 30% chance of getting something, right? You could write 0.7 and 0.3, or you could write 0.7 and 1 minus 0.7 for 1 minus P. And that 1 minus 0.7 is equal to 0.3. Same thing, but the nice thing about writing it as 1 minus P is it makes sure that you don't leave out any probability. Make sure that everything sums to 1, which is what you want, or else you're leaving out an option. So this here again, 0.5, right? 1 minus P, 1 P we saw with 0.5, 1 minus P, 0.5. Utility 2 was getting 0. So here, again, we replace that 1 minus P with 0.5. We replace utility O2 with 0. So then we're left with, you've got the choice of 0.5 times 100, right? Is equal to 50, plus 0.5 times 0 equal to 0. So 0.5 or 45, right? So in this case, if we look at this, and we take things like risk out of the equation, the expected outcome of the gamble is more than the expected outcome of the sure thing. Now, that doesn't mean if you choose the gamble, you're always going to do better, right? But the expected outcome, if 1,000 people take the gamble, right? And 1,000 people take the sure thing. On average, the people taking the gamble will do better than the people taking the sure thing. Now, there's some people who took the gamble, again, who are going to get zero, about half of them. So if you had 1,000 people, about 500 of them, right? So there's certainly some people who would have done better here than here. But on average, people would do better with this gamble than with the sure thing, on average. Nobody would actually get 0.5 here, right? People would either get 100 or 0. But on average, they'd be getting 50. People would be getting 50, and on average, people would be getting 45 here. Everyone in this case, because of it being 100. Now, I said at the start, there's no right or wrong answer here. Even though here it seems like, this one's more valuable than the other. There's no wrong answer because rational actor models do allow for different risk preferences, right? So some people, if there's a sure thing, are going to say that they prefer 100% chance of a sure thing versus, a certain percentage chance of a higher amount, right? So a lot of you probably, as I told you, you've got this gamble where you get $50, or you've got this choice where you get 45, right? This gamble where you get on average $50, but there's also a 50% chance that it's 0, right? And 50% chance 100. Many of you are going to look at this and say, just give me the 45. And that's okay. A lot of people are risk averse. Probably most of the time, more people are risk averse. And that's fine. That's not irrational. As long as you're consistent, right? As long as, like, say, we do this gamble again, and you consistently are risk averse in this type of gamble. If you're going back and forth, sometimes you're risk loving, sometimes you're risk averse, that doesn't make sense. But if we take somebody who's risk neutral, right? They are completely neutral. Say this was 100% chance of getting 50. And if we gave them this gamble and we gave them this sure thing, and both of them were valued at 50, a risk neutral person would be completely indifferent between the gamble and the sure thing. So assuming people are risk neutral, just for this exercise, right? You'd be better off taking this one to this one. But this, again, is just kind of showing an example how kind of expected utility theory at least is thinking that if we get these choices and we get these sure things, or we get these different set of choices, how is it people are making the decision as to which one's best for them? Turning a little bit more to IR, consider a choice to go to war. A state would choose war if the expected utility of war, which is always a gamble. There's no wars that are sure things. There's some that may look like it, where you may have a very high probability of winning, but wars are never a sure thing. Is greater than the expected utility of all non-war options, right? So there might be options of doing nothing where you know what you're going to get. There may be other options of trying different forms of diplomacy, economic sanctions, stuff like that, all with their own expected outcome. We expect to only choose war if the expected utility of all the different options with all the different probabilities and outcomes and utilities for each of the different outcomes is if when we combine it all together, it's higher than all the other options, right? So imagine this is the gamble for going to war. It's two evenly matched states, right? So you've got 50% chance of winning 100% of the territory, say, and you've got 50% chance of losing all of the territory, right? So this could be the outcome for war. And you would choose this, assuming risk neutrality, over, say, the other options do nothing, and you've got 100% chance of controlling 45% of the territory. Imagine, say, these, rather than being dollars, were amounts of territory, right? So two states are competing over kind of a borderland between them. And right now, the state controls 45%. If they do nothing, they're going to continue controlling 45%. If they go to war, they've got a 50% chance of winning 100% of the territory and 50% chance of losing all the territory or having none of the territory. Right? So this is the type of gamble where you would expect in this case for risk neutral people to choose this. Again, decision makers don't actually do these calculations in their brain. There may be some analysts in some department somewhere who are trying to model it out and give numbers to decision maker, but we don't actually assume people when they're making decisions actually do these calculations, but we expect that they behave as if they do. All right. So rational actor model, putting it a little bit more text. So that was a little bit more mathy. Now a little bit more text, kind of how Allison framed it. So governments select the action that will maximize strategic goals and objectives, right? So states have certain goals and objectives. They're going to choose the action that gets them closest to, these goals and objectives. The general principle can be formulated as follows. The likelihood of any particular action results from a combination of the nation's relevant values and objectives. So what do they want? Perceived alternative course of action. So in a given situation, what are the options available to them? So go to war, do nothing, economic sanctions, diplomacy. The estimates of various sets of consequences that follow from each alternative, right? So you do nothing, okay, status quo. Diplomacy, what are the possible outcomes and their probabilities? Economic sanctions, what are the possible consequences and their probabilities? And then war, what are the possible consequences and their probabilities? And then 4, a net valuation of each set of consequences, right? So taking them all together, okay, what is the expected utility of war? What is the expected utility of doing nothing? What's the expected utility of economic sanctions? And what's the expected utility of diplomacy? I think that was the last one that I listed. And you choose the best one. So that's the rational actor model. That was kind of the status quo. And a lot of scholars even past, so this again was written in 1961, a lot of the scholars even past them relied on, sorry, not 61, 71 must be, relied on this assumption. So before Allison wrote and then after, this is rational actor model is very, very commonly used. Many, and again, most of the theories that we've looked at so far, neorealism, neoliberalism, liberalism, all make assumptions that actors are rational. The second model is referred to as the organizational process model, right? And so this is acknowledging that when you're making foreign policy decisions, so the decision maker, makes their decision, right? But in terms of feeding information to the decision maker so that they can make their decision, but also in terms of implementing decisions, right? Decision maker says, we'd like to do something, right? That something doesn't spring into action, right? That something then gets sent over to a series of bureaucracies who put it in place, right? So the government says, I want to go to war, right? So they then send that over to, the Department of National Defense in Canada, or the Department of Defense in the US, or the Pentagon, right? And then the different military bureaucracies say, okay, well, these are the procedures that we follow for going to war in this situation. This is the steps we take for going to war, right? So it recognizes that any decision-making, bureaucracies are at play in terms of either helping to make it, in terms of feeding information, but also in terms of implementation. So how do bureaucracies operate? So if a nation performs an action of a certain type today, its organizational components must yesterday have performing or have had established routines for performing an action only marginally different from this action. At any specific point in time, a government consists of an established conglomerate of organizations, each with existing goals, programs, and repertoires. The characteristics of the government's action in any instance follows from those established routines and from the choice of government leaders on the basis of information and estimates provided by existing routines among existing programs, right? So if you send a problem over to Department of National Defense and say, what suggestions do you have here, right? The bureaucracy, Department of National Defense, already has established routines. So in situation A, we do this. In situation B, we do this. In situation C, we do this, right? So bureaucracies rarely, if ever, sometimes, but very, very rarely ever start from scratch with each different problem. They're not like, okay, this is a completely new problem, we're going to start from scratch. Instead, what they do is they put into categories, like that if this is situation type A, we do this, right? So if this is a conflict with this type of state, in this situation, we're supposed to follow this routine. If it's a different type of situation with this other type of actor, we're supposed to follow this set of routine. So each different bureaucracy has a set of routines that already exist and that are related to kind of behaviors that have been done in the past in marginally different situations, right? And so rather than starting from scratch, they look at what have they done in the past, and they use that to formulate the policy for today. So that's where they're saying, if a nation performs an action of this type today, its organizational components must yesterday have performing or have established routines to perform a similar action, right? So always we're, bureaucracies are proposing actions in based on what they've previously done, based on routines or processes that they've already created before. So organizational actions, what type of actions does this lead to? So activity according to standard operating procedures or SOPs and programs does not constitute far-sighted, flexible adaptations to the issue, as is conceived by the analyst. Detail and nuance of action by organizations are determined predominantly by organizational routines, not government leaders' direction, right? So the bureaucracy, when they're coming up with the information to send or with in terms of implemented decisions, whichever it may be, right? They're not necessarily caring or even thinking about the nuance of or the overarching purpose of the decision maker. What they're saying is we've got certain routines, we have certain standard operating procedures that we implement in certain types of situations. And if this is something that's categorized as a certain type of situation, this is how we deal with it. This can lead to problems sometimes, right? Like if the routine that's being selected, if the current situation is sufficiently different from previous ones, the routine that's being selected, the standard operating procedure being selected, may not lead to appropriate information or solutions or actions for the current situation. It's not flexible, right? It's not nuanced in terms of each different situation gets a proper in-depth analysis of how is this situation different, how is this situation unique, and how do we need to tweak policies. No, it's kind of a one-size-fits-all solution for everything that fits within certain categories. So there's limited flexibility and incremental change in terms of policies or actions. Major lines of organizational actions are straight. Behavior at the time, at one time is marginally different from that at behavior at time -1. Simple-minded predictions work best. Behavior at time +1, so in the future, will only be marginally different from behavior at the present time. So the behavior at the present time is very, very similar to the behavior in the recent past, and in all likelihood, behavior in the not so distant future will be very similar to behavior today. And that's because standard operating procedures are very, very, very slow to change, because if they're very quick to change, they wouldn't be, standard operating, and it wouldn't fit the bureaucratic model or how bureaucracies work. Now, this makes bureaucracies sound terrible, right? Like all they're doing is simple-minded, taking this super complex situation, and the government's trying to come up with this nuanced policy, and the bureaucracy kind of dumbs it down into these categories. And it makes them sound, on the surface, it makes them sound lazy and problematic. In fairness to bureaucracies, right, this is often the best they can do given constraints in terms of resources, so financial resources, information resources, personnel resources, time resources, right? Like the decision maker might be saying, I need the information within a day, right? And they don't have, all the information would need for a nuanced analysis would need to be collected, and they don't have the manpower and time to do so. The bureaucracy is being asked to deal with hundreds of different problems at the same time, and they just don't have the manpower and the resources to be able to go in depth in each of them. So this is the way that they can, with the resources that they're given, come up with this reasonable decisions in each of the cases and can get their work done, right? So there's also an understandable side to this. This makes sense given resource constraints. One would hope without resource constraints, we'd see something different. Once standard operating procedures are in place, even if there's an increase in resources, you'd probably still see something really similar. The third is in terms of bureaucratic politics model. Now, and so this is thinking more about kind of the decision-making group that's making decisions. So if you've got, say an international crisis, and you're bringing together different leaders from different departments, right? So say it's an international military crisis, right? You might have the head of the Department of National Defense. You might have the top general in the Army, the top general in the Navy, the top general in the Air Force. You might have the head of the security different agencies. You might have the top diplomat or the head of the diplomatic corps. You might have some of the different, and you might have the prime minister, and some possibly some other. You may have someone from trade or economics, international trade or economics department handling that to bring that side in. There could be other different leaders, but all of them are at the table. And rational actor model says, they're all going to sit there together and, weigh the different options, look at the expected outcomes, the probabilities, and choose the best one. But the bureaucratic model comes up with a different analysis of what leaders would do. So leaders who sit atop organizations are not a monolithic group. Rather, each is in its own right a player in a central competitive game. The name of the game is bureaucratic politics, bargaining along regular life channels among players positioned hierarchically within the government. Government behavior can thus be understood not as organizational outputs, but outcomes of a bargaining game, right? So each of these individuals sitting at the table, so the top generals, top of defense, top of intelligence, top of diplomacy, top of all the other ones, right? Yes, they want to come up with a good solution, right? But they also want to get resources for their own departments, right? The Army is going to look at most of the problems and say, the Army can handle this, give the resources to the Army because the Army's your guy for this. And the Air Force is going to look and say, no, the Air Force is the one to solve this. This takes some sort of a strategic bombing campaign. The Air Force has got this, give the resources to the Air Force. The Navy looks at it and says, no, this is a naval problem. It needs a naval blockade of some sort. You give the resources to the Navy. And if we look at the outcome, it's going to depend on bargaining, right? So each of these different departments or leaders of departments will have a certain level of clout in every government, right? So it'll depend on what alliances can they make to make decisions, who has more prestige or clout with, say, it's the prime minister's final decision it is. So who could be the most convincing, who could tell the best story, all those things. But so it's a form of bargaining between these different ones. And yes, they all want a good decision, but they also want to be protecting their job and their organization, their bureaucracy. So actions and intentions. Action does not presuppose intention. The sum of behavior of representatives of the government relevant to an issue is rarely intended by any individual or group. Rather, several individuals with different intentions contributed pieces which compose an outcome distinct from what anyone would have chosen, right? So what happens in the bargaining game, right? So you might have the Air Force and the Navy say, look, neither of us are likely working together to get what we want. So why don't we work together and use our clout together, use our power together and propose a joint solution, right? So strategic bombing combined with a naval blockade, right? Now, neither of them probably intended for that to be the outcome. Neither of them necessarily even thinks that a blockade combined with strategic bombing is the best outcome, right? If anything, just throwing those two together is a little bit of a nonsensical, in many cases, because they're working at counter purposes solution, right? But the Air Force wants the bombing and the Navy wants the blockade. And so that's what they come up with. And if together they get enough clout, that might be the decision, even though it's not what any of them individually would have intended. If you want to figure out in a decision-making scenario what each leader is going to be advocating, where you stand on a different issue depends on where you sit. And you may have heard that adage before, right? So they're always going to be, yes, again, trying to get the best policy, but they're wearing the hat of the organization that they're in. The Army is always going to look at a problem through the lens of the Army. The diplomatic corps is always going to look at a problem through the lens of the diplomatic corps. The intelligence community or leaders of intelligence are always going to look at a problem through the lens of the intelligence community. So you could figure out what policies people are going to be advocating based on who they are and what organization are they part of. So that's the third, the bureaucratic model, right? So both of these are countering to a certain extent, but differently, the rational actor model, right? Rational actor model saying everyone is kind of doing their cost benefit analysis and choosing the outcome or the means that's best for achieving the ends, right? The organizational process model is saying both in terms of implementing decisions, but also in terms of giving the relevant information and options to the decision makers, right? Those, in both cases, it's being filtered through organizations that are following standard operating procedures as opposed to this cost-benefit analysis, nuanced information gathering, nuanced processing. And then the bureaucratic politics model. So the decision makers then, again, in the organizational process model, may not have the relevant information or the best information that's required for the rational process model or the rational actor model. And then finally, the bureaucratic politics model is saying, okay, even if you got all this great information in, so forget about the organizational process model, even if you got all this great information in, we don't have this kind of rational in terms of everybody is looking at the information in trying to get the best means to achieve the end. Instead, people are trying to choose, each individual are suggesting means that's best for their individual organization, and that the kind of the collective outcome of that often produces means that nobody really intended for and that may not be the best for achieving the ends. Groupthink, which was developed by Irving Janis, or by Janis and Mann in 1971, or in the early 1970s, is another model for how groups make decisions. So bureaucratic politics was more kind of where you stand depends on where you sit. Groupthink looks at, if you have a group making a decision together, argue that the development of group norms that bolster morale at the expense of critical thinking. And that this is a problem for group decisions. So one of the most common norms appears to be that remaining loyal to the group by sticking with the policies to which the group has already committed itself, even when these policies are obviously working out badly and have unintended consequences to disturb conscience of each member, right? So in a group, you end up with certain group norms that of how people are supposed to behave in the group, right? And these don't necessarily go along with what we'd want from a critical thinking, rational decision-making perspective. And one of these most common norms is that essentially you don't rock the boat, right? So particularly if a decision's already been made, right? Even if somebody wouldn't necessarily normally agree with that decision, you go along with it. And you still go along with it even if evidence starts coming out. So you start implementing the decision and evidence comes out that this decision wasn't necessarily the best. You still go along with it. And even before a decision's been made, it could be even as far as, somebody, particularly somebody prominent, makes a suggestion, and rather than saying, kind of being you've been giving constructive criticism, you go instead with no criticism, right? So no critical thinking. You just go along with, to the group. Oh, so that's a great idea. Even though, normally you would think right at the outset, this isn't a great idea, and you could come up with some constructive criticism, you hold back from doing so. And so work by Janis and Mann found that this is a common tendency in groups making decisions. So what are the symptoms of groupthink? Well, they arise when members of decision-making groups become motivated to avoid being too harsh in their judgment of their leaders' or colleagues' ideas. They adopt a soft line of criticism, even in their own thinking, right? So even if it's in terms of ideas that they have, where if they're working individually to come up with a decision, maybe they'd be more critical of their own thinking, right? But if it's their own ideas or their colleagues' ideas or their leaders' ideas, they avoid being overly harsh in their criticism. If anything, you avoid having criticism at all. Now, Well, this means that they're very supportive of members of their group, right? The in-group is referred to members of your own group as being the in-group. So they're very supportive and very uncritical of ideas put forward and decisions made by members of their own group. They're very aggressive towards the out-group. So people who aren't in the group are anything decisions that they make or anything that they do is bad and is looked at in the worst light. Now, groupthink isn't necessarily inevitable. Groups can, in fact, often make better decisions than individuals. So this isn't necessarily to say that, you know, we should just be going with individuals making decisions. Groupthink doesn't, just because groupthink's a problem, I mean, still most of the time, groups are able to make better decisions than individuals. Part of the problem, though, is that the advantages of having decisions made by groups are often lost because of powerful psychological pressures that arise when members work closely together, share the same set of values, and above all, face a crisis situation that puts everyone under intense stress. And in particular, this last point, but even some of the other ones, right? If you're looking at a government making decision or a cabinet making decisions or a crisis team making decisions, they would share similar sets of values because they may often be from the same political party. They've often been working together, working closely together. Again, many of these groups in foreign policy decision are meeting together often, but in particular, the time when we want groups in foreign policy to be making the best decisions are in crisis situations. And that's when there's the highest level of stress. And it turns out that groupthink is the most likely to occur. So where advantages of group decisions are most likely to be lost are in the situations where we most want groups to perform well. And so that ends up being kind of a big problem. So let's go back to, so far we've kind of been looking at groups, so critiques of the rational actor model from kind of the group perspective. So we had the organizational process model about how bureaucracies work, the bureaucratic politics model in terms of kind of group decision making, where you stand depends on where you sit, and then groupthink, right? Another group problem or a problem that arises in group decision making. Now we're going to look at kind of individual limits to rationality, where people may not be able to behave in terms of what the rational actor model said. So Herbert Simon, writing back in the 1950s, prominent political scientist, economist, psychologist, kind of did a little bit of everything, shown and work by Herbert Simon. This, even though from 1955, has been, found to be what he says true. That there's a complete lack of evidence that in actual human choice situations of any complexity, these computations suggested by rational actor models can be or are in fact performed, right? So people, when they're making decisions, not only do they not make the calculations that are suggested by the rational actor model, expected utility model, but they don't even do as if they had. In a review of kind of the literature decades later on kind of testing rational, whether people are able to act rationally, find that pure rationality is something of fiction when applied to human behavior. So it sounds nice on paper, but if we actually look at how people make decisions, there's very little evidence that people actually act in accordance with the predictions of expected utility theory. Even going back to, so we had some games that we did in the neo-level institutionalism, and Prisoner's Dilemma I talked about is one of the most common games, and we saw that defect, right, is the equilibrium position. If everyone is kind of playing, playing rationally, you never have any incentive to, whether the other one chooses to cooperate or defect, you prefer to defect, right? So both actors playing together should come to defect. That's the rational thing to do. It's rational in that game to defect. In fact, though, when people play the game in experiments, people play the game in incentivized lab experiments where you say could even get monetary rewards for playing. Some people perform according to expectations. Many people do, but many people actually cooperate. I was suggesting they just did not understand the game, or people aren't operating in the same way that the rational actor models are expecting. So a lot of research, including by Daniel Kahneman, Nobel Prize winner in economics, finds that humans rely predominantly on intuitive unconscious processing, or what's referred to as system one processing, rather than deliberate and systematic processing. So when we're making decisions, there's kind of two systems within the brain. There's the one that we think about when we're talking about rational actor model. So the one that's deliberate and systematic, right? So it takes all the different options, it takes the probabilities, it runs through these options, all the different probabilities, and makes the best choice. Deliberating, rational. But there's also this intuitive unconscious system that kind of, if you think about intuitive or gut, right, feeling. And it's unconscious. We're not aware we're doing it. You're not deliberately thinking, you're just doing. And humans rely predominantly on this intuitive conscious processing, right? So think about if you wake up when you wake up in the morning and you're choosing what to have for breakfast, do you weigh all the different options, or do you just go and do? Right? Well, you actually did some thinking. You're just not consciously usually aware of having done it. You just go with your intuitive unconscious processing and make your decision. Well, it turns out that most of our decision making actually goes along to that system. System one relies on simplifying heuristics. You could think of heuristics as kind of rules of thumb. So kind of similar to kind of your standard operating procedure type thing that we had when we were talking about bureaucracy. The brain kind of has its own set of standard operating procedures, right? Simplifying rules for making decisions in certain circumstances. So rather than deliberate action, it just uses the heuristic, the rule of thumb, to make the decision. These heuristics, this isn't to say heuristics are bad, right? Heuristics, most of the time, in most situations, again, in most situations, we rely on our intuitive unconscious processing, and in most situations, we make good decisions, right? If heuristics always led to bad decisions, if rules of thumb always led to bad decisions, then evolution would have selected away this type of decision making, and so people who has lower tendencies to do this would have had an evolutionary advantage, and so this would have gradually been selected away, but it hasn't, right? So most of the time, these heuristics are good. The problem is there's certain times where they can be sources of error, and they can produce biases in decision making. And biases are defined as departures from the normative rational theory that serves as markers or signatures of the underlying heuristic. So bias occurs if you systematically, in certain circumstances, make decisions that are different than what you would be wanting that it would be the rational decision. Because again, these heuristics often most of the time lead to outcomes or behaviors that are the same as what you would expect if someone was going through deliberate, systematic, rational calculation. But there's some times where in certain circumstances, with particular heuristics under certain circumstances, where you systematically end up with bad decisions, bad processing. So to understand foreign policy, cognitivists focus on the simplified mental representations of reality that decision makers use. So what are the heuristics that decision makers used in making their decisions about alternative courses of action in foreign policy? So that's been in the last several decades, one of the growing areas of research on foreign policy is understanding how is it that individuals, because at the end of the day, it's individuals who make decisions. And at the end of the day, it's the president or the prime minister or some individual who's implementing decisions. How is it that they actually make them? So we're going to just look quickly at a couple of the kind of the heuristics and biases that can occur. So one being the fundamental attribution error. So fundamental attribution error is not always an error. Like in any kind of heuristic situation, oftentimes the decision that comes here would be optimal, but there's certain circumstances where it's not. Research on the fundamental attribution error has found an actor-observer different in attribution. So attribution is how we assign causes. So What is the cause of an event? So if we're trying to explain what the cause of an event, that's a case of attribution. An actor-observer, so actor being the person doing, observer being the person who's observing. So fundamental attribution error states that the belief that the negative behavior of others are caused by dispositions, but our own negative behaviors are caused by situational factors, right? So say something, there's a negative behavior. So you and I do poorly on a test, right? And we want to explain why did we do poorly on the test. When we're looking at the negative behavior of another, if I'm looking at the negative behavior of another, so why did you do poorly? Well, I'm going to point to a cause based on your disposition. So it's something to do with a personal trait of you, right? So it could be that you're lazy. It could be that you're not very smart. So something in your character. If I look at my own negative test results, I'm going to look to a situational factor. So I'm not going to look at an element of my character. It was I wasn't able to study or concentrate in studying because of the construction outside of my window, or the test was too hard. The teacher was unfair in grading of the test. That's why I did poorly. So it's something where it's not having to do with me. Conversely, positive behavior of others are caused by situational factors, whereas our own positive behaviors are caused by our own dispositions. So similar examples, someone does something positive, positive outcome on a test, so doing really well. When we're explaining why others do well, we point to situational factors, right? The test was too easy. The teacher made a mistake in grading and gave them too many points. It was luck. Where when we look at our own positive behavior, it's caused by our dispositions. I'm hardworking, I'm really smart, I'm good at taking tests, any of these different things. So turning it to foreign policy, right? How can this be disruptive? Well, let's think of things like, so there's been instances where countries have shot down planes, civilian planes, right? If you shoot down a civilian plane, you're going to explain it in terms of a situation, right? So the pilot did not accurately identify themselves. We are asking them to identify themselves. They did not. The plane was taking provocative actions, right? So it's not our fault we shot them down. Under the circumstances, we had no choice but to do so. But so the other country, though, when they're looking at it, was their plane shot down by you, and they're looking at the situation, they're going to be using the situation to explain. They're going to be using, the disposition to be explaining it. Because so they're going to be looking and saying it's because you're aggressive, right? Or some other negative aspect about your character. You're reckless, aggressive, something like that. And so both sides are looking at the same set of information, right? Both sides have the same information about the plane shot down under these circumstances. Both are looking at the exact same information, and the policy responses that would be suggested by both are completely different, whether it was a reasonable action based on the circumstance, and whether it was a reckless, aggressive action. And then it goes even further. So the responses suggested by both are different, but then also the interpretations. So say you believe that based on your looking at the evidence that you had no choice based on the circumstance, right? And then you see the other side gearing up for war or talking about how there needs to be retribution for it. Well, based on the circumstances, that seems completely nonsensical, right? And so that could lead to further problems. So how we explain different outcomes, right, really depends on whether you're the person acting or the person observing. Belief perseverance. So foreign policy beliefs often resist change. Cognitive mechanisms such as selective attention to confirming evidence, denial, source derogation, and biased assimilation of contradictory evidence buffer belief from refutation. Once you already have a belief on foreign policy or on any issue, it's often very hard to change that belief, right? So we pay only selective attention to confirming evidence. So we only pay attention to evidence that confirms our belief. We never look for or pay attention to evidence that could challenge our beliefs. If we do see evidence that could challenge our belief, we're often in denial about it. Source derogation means, so we see some information that we don't like, and we don't necessarily know how to deny it, so we attack the source. All the information didn't come from a credible source, so we can't trust this information. The people, publishing this study or giving the information aren't reliable. And then even bias assimilation of contradictory evidence. So even if we get contradictory evidence, we find a way to fit it in to kind of our existing story in a way that it doesn't end up contradicting our belief. So again, all of this in terms of all of these different processes for kind of bringing in information can lead to kind of biased interpretation of new information. And then finally, so far we've kind of been looking at, so heuristics and bias, many of them suggest, and a lot of the cognitive literature suggests that the decision makings that people make, right, that there's a whole bunch of departures from the rational actor model. We're going to conclude today with prospect theory, which is kind of based on research in behavioral economics and in psychology, is trying to kind of produce an alternative, psychologically based on how people actually act model, complete model, similar to how rational actor is kind of more of a complete model, an alternative model. So in the questionnaire that you got, so I, on the constructivism day, I circulated a set of questionnaires. And what you didn't know when you were completing them was that there's two different versions of the questionnaire. So half of you got one questionnaire and half of you got a different questionnaire. And so here's one of the examples that half of you got, or the example half of you got. So if the following scenario were to take place, which program would you choose? So imagine that Canada is preparing for the outbreak of a rare disease which is expected to kill 600 people. Two alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequence of the programs are as follows. And I altered the example that was in the original publication to make it Canada-centric, but this is coincident given COVID that it's this example. So in this case, program 1, 400 people will die, and program 2, there's a 1/3 probability that nobody will die, and a 2/3 probability that 600 people will die. And half of you got this scenario. So imagine that Canada is preparing for the outbreak of a rare disease, which is expected to kill 600 people. Two alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the programs are as follows. Program A, 200 people will be saved, and program B, there's a 1/3 probability that 600 people will be saved and a 2/3 probability that no people will be saved. So let's look at the expected outcome. Let's kind of do that, the rational or expected utility calculations for both of these. So let's start with program 1 and program 1. So again, this is a sure thing versus the choice between a sure thing and a gamble. So 400 people will die. So let's think in terms of utility, because we need a way of calculating utility. So we've got 600 people, and let's put utility for each person who's alive, right? So if 600 people are alive, that's a utility of 600. If 0 people are alive, that's a utility of 0. 300 people are alive, utility of 0. So let's put it like that. So 400 people will die. How many people are alive then? That means 200 people are alive. So the expected utility here, 100% chance, 200 people will be alive. Now, program 2, 1/3 probability that nobody will die. Nobody will die, 600 people are alive. A 2/3 probability that 600 people will die. 600 people will die means 0 people are alive. So 1/3 probability that nobody will die, so 1/3 of 600 is 200, plus 2/3 probability that 600 people will die. 2/3 probability times 0, 0 people alive, 2/3 times 0, 0. Expected outcome here, 200 as well. So And you could calculate this, go through it like the steps that we did earlier in the lecture, if you want to calculate this out. Normally in person, we kind of do it up on the board, and I'd have people kind of calculate it for me, but that's not particularly feasible here. But program 1 and program 2 are identical in terms of the expected outcome. In both cases, 200 people are expected to be alive. The only difference is one's a sure thing and one's a gamble, right? So your choice between program 1 and program 2 really comes down to, are you risk averse or risk loving, right? If you're risk averse, you're going to go with the sure thing. If you're risk loving, you'll go with the gamble, right? Advantage of the sure thing is that at least you know for sure some people are going to be alive. Advantage to the gamble, yes, everybody could die, but you're also in a scenario where everybody could live. Now let's look at A and B. Okay, 200 people will be saved. That's easy. 100% chance, 200 people will live. Expected outcome, 200 people living. Program B, 1/3 probability that 600 people will be saved, and 2/3 probability that no people will be saved. Okay, 1/3 probability, 600 people will be saved. Expected outcome there, 1/3 times 600, 200 plus. 2/3 probability that no one will be saved. 2/3 times 0, 0. 200 plus 0, 200. So program B, expected outcome, 200. So again, program A, program B are identical. The only difference being in terms of one being a sure thing and one being a gamble. So again, here, difference comes down to your risk tolerance. Do you prefer the sure thing? Do you prefer the gamble? So kind of to summarize, program A and program 1 are completely identical. They're sure things that 200 people will be alive. Program B and program 2 are also completely identical. In both of them, it's a gamble, and it's a gamble where the expected outcome is 200, and where there's a 1/3 probability of everyone being alive and a 2/3 probability of no one being alive. So they're all completely identical. A and 1 are identical. So the difference between, if you prefer A to B, then you should prefer 1 to 2, because they're identical. And so the decision between A and B and between 1 and 2 is based on your risk tolerance, right? So if you prefer A, you should prefer 1. If you prefer 2, you should prefer B, right? That's the rational thing to do, right? Now, here's the responses, and this is bringing together your responses with some of the responses I've had from previous classes, just so that we have enough numbers and you can't say, oh, well, this is just a fluke. So this is with several hundred other students I've had in past classes, and I just add yours in and kind of update the numbers, right? So now you might have noticed that in this A versus A and B and 1 and 2, difference was in terms of whether it's written in terms of lives saved or lives lost. So here, people would die, 1/3 probability, nobody will die, 2/3. So this is in terms it's discussed in terms of dying, lives lost. This one is written in terms of 200 people will be saved, lives saved. So if we present the options in terms of lives saved versus lives lost, we see a complete change in people's risk preference, right? When it was termed in terms of lives saved, 61% of people preferred the no gamble option. They preferred the sure thing, the guarantee 200 people will live. So the majority, when it was put in terms of lives saved, didn't want to gamble. Conversely, 71%, so a stronger majority even, when it was framed in terms of lives lost, preferred the gamble. Now, again, this from a rational perspective makes no sense, right? Because both of the blue columns are identical, right? Identical in terms of expected outcome, but also in terms of risk. And both the red columns are identical in terms of outcome and also how we get there in terms of each of the different options and the riskiness, and the probability, right? So both red columns are exactly identical and both the blue columns are exactly identical. But in terms of how the language is presented, made a change into what options preferred, and that's based on all the lists that we had from expected utility doesn't make sense. So when it's framed in terms of saving lives, the majority favors the sure thing. When framed in terms of people dying, the majority preferred the gamble. And so Kahneman and Tversky developed prospect theory as kind of a model that could challenge expected utility theory. So we started with expected utility theory. And they argue that there's what's called a framing effect. So choices are affected by the reference point. And people tend to be more risk averse in the domain of gains, and people tend to be more risk loving in the domain of losses. Let's start quickly with reference point. So in our original example, that's in terms of the amount of people alive, right? So in one of the different cases, they're talking about 600 people are alive and some will die, right? So that's a loss. Everybody's alive and then some people are going to die. In the other example, it's kind of presented as if everybody is dead, and if we do this, some people will be saved, right? So we're in terms of gaining people. Right? So in this case, when framed in terms of saving lives, majority favored the sure thing, because you're in the domain of gain. So affected by the reference point. Is the reference, in both cases, we're talking about 600 people and some could be living and some could be dying, 200 people being alive at the end, right? But in one case, your starting point is everybody's dead and we're gaining 200 people. In the other one, everybody's alive and you're losing 400 people. Think about it in this way too, to kind of help with the framing effect. Think about 0 degrees, right? 0 degrees Celsius. Is that hot or cold? Well, as Canadians, you'll probably know that the answer to that is it depends, right? First time you hit 0 degrees in the fall, right? Everybody's running for the winter jackets, it feels cold. What happens though in the spring when you hit 0 degrees, or take 5 degrees even, right? First time it hits 5 degrees, everybody's hanging up the winter jackets and it feels like summer's coming, right? But in the fall, we're used to the summer where there's warm temperatures. 5 degrees feels cold. In the winter, where we're used to colder temperatures at 0 or 5 degrees, it feels warm. So how we approach this temperature, 5 degrees is 5 degrees is 5 degrees. Doesn't matter when in terms of like the molecules moving in air, the actual amount of heat in the air. It's identical, but the way it feels to us depends on the reference point. What are we comparing it to? And in terms of, to understand, people tend to be risk averse in domain of gain and risk loving in domains of losses. Think about the casino, right? What happens when people lose in the casino? Do they stop and say, look, I lost a little bit, it's time to walk out? No, they're all sure that the next hand is going to win everything back. I'll play one more hand. If I play this hand, I'm going to win it all back. And then they lose that hand. Or like, oh, don't worry, the next one, it's fine. I put this down, I'm going to win it all back. And then they lose again. What happens to the people who win? The people who are up, some of them will stay too long and end up losing it again. But a lot of the people who end up are able to, I could stop. It's great. I've had a good day. Time to walk away. Now, some of them certainly will re-lose it again based on just the probability of playing. But, it's easier to just walk away. Oh, I won $100. That's nice. I don't need to try to win more. Why would I? I'm up 100. Yeah, winning more would be great, but I don't have to. Oh yeah, I could play one more hand. I could double it. Whatever. I can go home or go spend this on something else. Go buy a drink. Go see a movie. Go to dinner. I'm happy, right? But the person who's losing, right, is more risk loving. I can win this back. I can win this back. I can win this back. And you see this also in foreign policy in terms of behavior in war. I'm losing the war, gamble for resurrection. If we stay a little bit longer in the war, things will turn our way. And So you see an element of that in foreign policy as well. And so prospect theory was developed in psychology and in economics, but imported into IR increasingly to try to look at how do things like reference points and domain of gain and domain of losses affect decision making. All right, so that's it for today. Next time we will be talking about public opinion.